Hi, welcome back everyone. How are we doing today again? Alright, so my name is Godwin. Just in case this is your first time of seeing me on this channel, um, nice to have you back again. So we continue with our probability series, and we are going to be having a class on probability with two or more events. So I don't know if that's really a title or something, but just kind of flow with what I'm about to do. Okay. Now, we are starting with what we call mutually exclusive events. So in probability theory, what do we call mutually exclusive events? Of course, mutual simply means having something in common. So when we say we are looking at mutually exclusive, that is, there is nothing in common. All right. So if you have mutual respect for each other, that means I respect you and you also respect me. But if it is mutually exclusive, that means one of us, right? It's either of us that is doing the respecting of the other person, while the other person is not reciprocating it. So that's like the central idea of mutual exclusive. So we can demonstrate that using Venn diagrams. The first, you have this, you have the circle A and circle B. Okay, and we see that there's an intersection in between the two, and that intersection is equal to C, right? So here, these events are not mutually exclusive. So because A intersection B gives you a C, right? There is something in common, right? And by the time we look at the second example here, we have circle A on its own and then circle B on its own. So there is no intersection. They are kind of disjoint, or let me say disjointed, something like that, and A intersection B is 0. So these two events, A and B, are mutually exclusive here, while here they are not mutually exclusive. That's like the central idea of that. Now, for example, if I say that when a coin is tossed, like we did the other day, what is the probability of getting a head and a tail? Right? You have a coin, you toss it. A coin has two sides, this side and this side. You throw it, right? You only get one side. You can't get the two sides at the same time. So, like getting a head and a tail is mutually exclusive. Do you understand? So, like the probability of a head and a tail is going to be equal to 0. So probability of, let me call it H, H intersection tail equals 0, right? So just in case. Now we are looking at a case of two dice. Now after two dice, we're looking at a case of what do you call it now? Two or three coins, right? And then see what the sample space is going to be, because by the time you're working with the probability, by the time you are trying to solve the probability of two dice, two coins, there's a little, there's kind of a sneaky thing about it, right? Because normally the sample space of a die is 6. Remember from the last class is 1, 2, 3, 4, 5, 6. And then you might be presuming that okay, wow, the sample space for two dice, right, should be 12. Right? That is 6 for this die and 6 for the other die. So let us see if it's going to be true or not. Alright, so this is for the first die. 1, 2, 3, 4, 5, 6, right? And this is for the second die, 1, 2, 3, 4, 5, 6. So if you were to roll two dice together, what are the different possibilities of outcomes that you're going to get? In other words, what is the sample space going to be? Now, if I toss the first die and I get 1, right? If I toss the second die, do you understand? I can get between 1 to 6. If I toss the first, I got 1. If I toss the second die, right, I can get between 1 to 6. So which is saying that for 1 alone, right, if I toss the first and I get 1, so here I'll be having 1, 1. That is 1 for the first die. I have 1 on the second die. Then I have 1 on the first die still. Then I can have 2 on the second die. 1, 3, 1, 4, 1, 5, 1, 6. So if the first die is 1, there are 6 different combinations of the second die that can go along with one that we got for the first die, right? So the same thing, if the first die happens to be 2, there are 6 different outcomes. So you have 2 on this die and 1 on the second one, 2 on the first die, 2, 2. So we go like that: 2, 3, 2, 4, 2, 5, and 2, 6. Okay, what if the first one is 3? So we have 3 and 1, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. I could have written out all of these things on my own, but I just want you to like follow through. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Then 5, 1, 6, 1, 5, 2, 6, 2, 5, 3, 6, 3. I'm just trying to write the 12 together. 5, 4, 6, 4, 5, 5, 5, 6. Then we have 6, 5, 6, 6. So let's count the sample space. So we have 1, 2, 3, 4, 5, 6. We also have 1, 2, 3, 4, 5, 6. So we're having 6 columns, right? 6 columns, right? 1, 2, 3, 4, 5, and then we have 6 rows. 6 times 6, 36. So the sample space of 2 dice, sample space, if we were to throw or yeah, roll 2 dice, you have equals 36. So whatever you are doing now is going to be equal to 36. Okay, so now let's try to like leave this and solve a couple of questions. So here we have these questions. 2 dice are thrown together. What is the probability of getting A, same number, and the same number on both uh, die? Then B, a sum equal to 7, right? You get a number on the first one, then you get a number on the second one. By the time you add the two of them together, they give you 7. And C, at least 1 5, right? At least 1 5. That is, the first die might be a 5, or the second die might be a 5, while the first die gives you a different number. Or then at the end of the day, both of them give you 5 5. No, the meaning of at least, right? It's either one of them gives you a 5 and the other doesn't, or the two of them give you 5. Do you understand? A 5 5. So now let's start. So the probability of getting same number. Okay, so we solution. So P of same number equals, now look at it, look at our sample space. So same number, you have 1 1, you have this 1 1, 2 2, 3 3, 4 4, 5 5, and 6 6. That's the only place where you get, same number. So you have how many of them? 1 2 3 4 5 6. Remember our formula, f over n, right? So we have 6 divided by total sample space 36, and that gives us a 1 over 6. Simple. Now that's for A. Then B, what is the probability of getting a sum that is equal to 7? Probability of getting a sum equal to 7. Now let's look at it. We have 1 plus 6 will give us 7. 1 plus 6 will give us 7. 2 plus 5 will give us 7. 3 plus, oh, I use 7 to represent the first one. Let me use black now. 1 6, 2 5, 3 4, 4 plus 3, 5 plus 2, 6 plus 1. 1 2 3 4 5 6. So we also have 6 over 36 again. That gives us a 1 over 6. Alright. Then the probability of getting at least 1 5. Probability of getting at least 1 5. Alright. So it's either you have a 5 and or you have 2 5. And if you look at this place, you have 5 here. So there's a 5 on the second die, and then there is 1 on the first die. So you have 1 5, then you have 2 5, you have 3 5, 4 5, 5 5, 6 5, right? So you still have 1 2 3 4 5 6. All right. So this is at least 1 5. This is just 1 5. This is just 2 5. This is 3 5, 4 5, 5 5. So like 5 of them would have at least 1 5. Then there is one that's going to have 2 5s, because the question said at least 1 5, right? So it's either you have a 5 on one and you have a 5 on the other, or you have 5 on both, dice. So again, we have 6 over. No, is that all? No, that's not all. That's not all. 1 5, 2 5, 3 5, 4 5, 5 5, 6 5. And by the time you come here, nice, that's good. You cannot remember, right? Thank you. So you have 5 on here. This is at least 1 5 again. 5 again. There's 5 here. There's 5 here. There is 5 here. There is 5 here. Okay, I think we're done. 1 2 3 4 5 6. Right? Then we also have 7 8 9 10. We counted this guy before, so we now go to this one. 11. So we have 11 over 36. Basic. Yeah, that's so smooth. Is it not smooth? Now let me kind of show you a calculation, the way you can calculate and then get 11 over 36 as well, right? For this second die. Okay. Now we know that for the first die, how can I solve that? Maybe I should erase this guy because I think I'm done with it. Yeah, I said formally, let me say mathematics. Should I say mathematically or it's not algebraically now? Anyway, don't really bother yourself. So let me just put mathematically. So how do we find the probability of at least one five? Okay. So since we have two dice, yeah, let us call them die A and die B. Okay. So the probability of having a five on the first one is 1/6. This shouldn't be a problem now. We did this like the other time. And also the probability of having a 5 on the other die is still 1/6, right? Okay, probability of having, let me call it like 5 on maybe die A. I don't know if this is meant to be a correct symbol or something like that. Then probability of having a 5 on die B is also 1/6. Are you following? So what is the probability of not having a 5? You see where it comes in? So the probability of not having a 5 on either die, right? That's 5. What did we do that? Complement. That's good. 5 complements is going to be equal to 5/6. This shouldn't be a problem, right? Okay. If you really understood what we did in the previous class, it shouldn't be a problem. So if you can have 5 just once, then what are the other possible events that are on a die that is not 5? Okay. Yeah, so you have 1, 2, 3, 4, and 6. These are 5 things. 5 divided by 6. Okay, so now we are rolling 2 die. So the answer is going to be P of at least 1 5 is equal to probability of having a 5, probability of having a 5 on the first one. So let me say probability of A, okay, having a 5 on the die A, right? Intersection B prime, B complements. So here you have a 5 on die A, but you don't have a 5 on die B because you are rolling 2 dice, right? So probability of having it's this and this die and this die. Okay, then plus probability of you don't have a 5 on die A now, A complements intersection, you have a 5 on die B. You understand? So here, because the question says at least 1 5, so you have 5 on die A, you don't have a 5 on die B, right? Then plus you now have a 5 on die B, you have a 5 on die A. Are you following? Then the last possibility is that you can have a 5 on the two of them. Are you feeling it? Right? Is it hard? Okay, it's not hard. So what's the probability of having a 5 on die A? So here we'll be having 1/6, right? Multiplied by, because it's die A and die B, so that's a multiplication. Multiplied by 5/6. So you're going to have a 5 on die A, you need to have on this. Then plus, you are not having on die A, so you have 5/6 multiplied by 1/6. Then plus, you're having on both die, so 1/6 multiplied by 1/6. So what are we getting? 1 times 5. So you have 5/36 plus same thing, 5/36 plus 1/36. So because they have the same denominator, just add everything up. 5 plus 5 is 10, 10 plus 1 is 11. So we have 11/6. So that's it. Yeah, that's it. You have a 5 on the first one, and you have a 5 on the first one, and you don't have a 5 on the other one. Plus, you have a 5 on the other one, and you don't have a 5 on the first one, which is this. Plus, you have a 5 on the first one, and you have a 5 on the other one as well. So the and, that's how you're multiplying in brackets. Then, just add everything together. Possibility of this or this, then in addition to possibility of this or that. All right. So we've been able to I think that's what we got here. Do this and this. So the next part of this class, which is the final part before your assignment, is to look at the sample space when you're looking at tossing two or more coins, like two or three coins. That's just what we are going to limit ourselves to. Okay, a case of two or three coins. Okay, fine. When you toss a coin, you can either get a head or a tail. Okay, like we've been saying since. So you toss the first coin, you can either get a head or a tail. But then if you happen to have two coins, the other coin as well could either give you a head or a tail. A head or a tail. So what happens when we toss the two of them together? What are the different possibilities that we are going to get? So the first one might give you a head, and the second one gives you a head as well. So you have H. The first one might give you a head, the other one might give you a tail. You have HT. The first one might give you a tail, and the other one gives you a head, TH. And the first one might give you a tail, and the other one gives you a tail as well. So you have four sample space. 1, 2, 3, 4. Right? Sample space equals 4. Cool. Now, what if we have three coins? So what's going to be our sample space if we have three coins? Okay, if the first one is 2, the second one is 2, 2 plus 2, 4. And when we have the third coin, that should be 4 plus 2, 6. Is that right? Now let's see. So this is the sample space for tossing two coins. What we have here, right? So I'm going to write each of them out. So you have now you have H. You've already tossed two coins. You have HH. You have HT. Then you have TH. This is the result for tossing two coins. Then you have TT. So you're now having a third coin that also has a head or a tail. Alright, so now you've tossed the coin twice, you got this. When you toss this with the third one, you understand, when you toss three coins now, you have H, 3S, or 2S and the tail, HT. Then you have HCH. Let me do something like this. Okay. Alright. So HT, HTT. Then we have TH and H, THH, that is a tail and two heads. Then a tail, a head, and a tail. Then a tail, a head, a tail. 1, 2, 3, 4, 5, 6, 7, 8. So it's not 6. You see the magic, right? So sample space equals 8. So I toss a coin, or I toss three coins simultaneously, the different outcomes that you may get have like there are 8 possibilities, of the different outcomes that you may get. Now let's begin to answer questions. Okay, the first question here says that a coin is tossed 3 times. Find the probability that you get exactly 2 of the 3 tosses come up head. Now a coin is tossed, I think, should I just jump to this? You have where a coin is tossed twice. Okay, let's just do this. The first one, we are looking at 2 coins, right? So question 1 is, what's the probability of getting a head or tail? H or is union of head or tail. Okay, where you toss 2 coins simultaneously, head or no. Should it be head or tail? No, it should be head, 1 head and 1 tail. 1 head and 1 tail. So like 1 head and 1 tail. So you have 1 head and 1 tail here, right? This is head, so you don't take that. Then you have 1 head and 1 tail here as well. So you have 1, 2. That's 2 over 4. That's the only place where you can have one of them being a tail and the other one being a head. 1 over 2. Okay, so let's say there is a second question that says, what's the probability that head comes first? Okay, probability that head comes first. Okay, so what's the probability that you have head first? You have head first here, you have head first here. So just have 1, you have 2 over 4 again. That's 1 over 2. Then question 3 says, what's the probability of having two tails, T and T? Two tails. By the time you look at it, the only place where you have two tails is here. So you have 1 divided by 4. 1 divided by 4. That's that, right? That's that. Now, let's go and look at a case of 3 coins. Okay, so the first question here says, exactly 2 of the 3 tosses comes up head. Exactly 2 of the 3 tosses comes up head. Exactly 2. That is, you are in all of your answers, you'll be having 2 heads. 2 heads. So exactly 2 of the 3 tosses. If you look at a case of this guy, so you have 3 different outcomes. Head, head, head. So they're like 3 like that. So the question is now saying exactly 2 of the 3 tosses comes up head. Okay, so probability of exactly 2 heads equals, our sample space is 8. So exactly 2 of the 3 tosses comes up head. So that means we can't pick H, H, H. Because it says exactly 2, only 2 of them comes up head. So we come and look at this guy. We have 2 heads here. So this is 1. We have 2 heads here, even though it is HTH. This is 2. We have 2 heads here. This is 3. Yeah, we now have 2 heads again. So we have 3 times, we are going to be having exactly 2 heads of 3 divided by the entire sample space, which is 8. Now the next one says the last 2 tosses comes up tail. Probability last, let me just say last 2 tails. Let me just put it that way. The last 2 tosses comes up tail. So you are looking for where tail and tail happens to come at the end. So you have TT. The last 2 tosses come up tail. Okay, we have here the last 2 tosses comes up tail here. Second place, tail, okay, 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 okay. So we have this, and then this. Even though these are 3 tails, but at least the last 2 tosses came up tail. So you have this one and this one. Am I missing something now? Well, if I'm not, so that's just 2 over 8. 2 over 8, which equals 1 over 4. Alright. Then the last one says all heads, no, all 3 tosses come up the same. All 3 tosses come up the same. So that is, you either have all heads, right, or you have all tails. All heads or all tails. I feel like writing here seems more comfortable for me. So all 3 tosses come up the same. So we are looking at probability of either H, 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 right, and T, T, T. That's basically what we're looking for. So where do you have that? This is 1 and this is 2. So only 2 of that. 2 over 8, which is equal to 1 over 4. Are you enjoying yourself? Because I think I'm enjoying myself here. Now, the last one is probability that the second toss comes up head. The second toss, that is, you have 3 outcomes. So the second one comes up head. So probability that second toss is head, comes up head. So equals, so when you have second toss coming up head, you have it here. This is head. The middle, head here. That's number 2. Not here, not here. Head here. Number 3. Head here. Number 4. That's the second toss anyway. You understand? Out of 3 tosses, 1, 2, 3. So it's 1, 2, second, okay, 3, 4. So that's 4. So we have 4 over 8, which is 1 over 2. Alright, so that's it about this class. If you have any questions, the comment section is there for you. And if you think there are needs for clarifications, of course, put it there. And if you want to appreciate our work, because I'm not asking you to pay money, man, you can look for us and send us money too. It's not bad. Alright, well, thank you. Okay, I want to thank you a lot. So the next thing that we are going into now is the assignments. Okay. We have an assignment on the board. Question one, two dice are thrown. Find the probability of getting two even numbers, an odd and an even number, at least one three, and at most one six. Then you have a question two, which says if two coins are tossed, what is the probability of getting a head or a tail? And B, a head and a tail. So I think I already solved one of these, but it's okay. It's okay. For MOG School of Economics students, you know where to submit your assignments for them to be evaluated and corrected if need be. And so in our next class, we'll be looking at contingency tables and conditional probabilities. Yeah, I think so. So thank you very much. See you there. Bye. Have fun.